Let's look at Trig lesson number 3, applications of reference angles, on page 157 to 161 in your workbook. And so what we're building on is your knowledge of rotation angles and reference angles in the cast rule that you've looked at in the previous 2 lessons. The key thing that I want to highlight is that you're looking at the exact trig ratios. So that means I do not want to see any decimals whatsoever. We're going to frequently see some radicals, which you guys will recognize as being irrational numbers. That means that they are non-terminating, non-repeating decimals. So if you write them out as decimals, they are no longer exact values. So take a moment and hit pause and just review what each of your rotation angles are and how that relates to the reference angles in each of the quadrants, as well as what that means for the cast rule. Meaning the cast rule tells us in which quadrants will the ratios be positive or negative. So just hit pause for a moment and read through the review notes. Now just reviewing at the bottom of the page, it says the trig ratios for an angle in standard position with a point P given by XY on the terminal arm, and OP is equal to RO, of course being the origin, is equal to RYR, R is being the thought of the radius if we drew a circle around, so then that hypotenuse would also be the radius of the circle. So y sine of theta is equal to y over r, reminding ourselves that if we have point P given by x and y, the opposite, remembering that sine is equal to opposite over hypotenuse, so then the opposite of angle theta is y, and over the hypotenuse r. Cosine of theta is equal to the adjacent over the hypotenuse, which is why we're looking at x over r, and tangent of theta is equal to opposite over adjacent, or y over x. So let's take a look at that first class example on the next page. So it says that point -3, 2 lies on the terminal arm of an angle theta in standard position. So let's go through and draw that on first. So -3 and 2, so that puts us somewhere about here. And so given us, if we know that this is actually our angle theta, our rotation angle, but this is our reference angle here, recognizing that they have exactly the same trig ratios except for possibly the positive and negative. So knowing that our x is -3, our y is 2, let's take a look at calculating what OP, or origin to the point, or the radius is. So we know that r squared is equal to x squared plus y squared, or r squared is equal to -3 squared plus 2 squared. R squared is 13. That tells us then r is equal to root of 13. So we can then take a look at our trig ratios. So sine of theta is then equal to y over r, or since y is 2, we're looking at 2 over root 13. Cosine of theta, since it's x over r, adjacent over hypotenuse, we're looking at -3 over root 13, and tangent of theta, y over x, is 2 over -3. So a couple things to just remind ourselves of as well is the cast rule, so CAS t, and because we're dealing with the second quadrant, we know that sine is the only trig ratio that's going to be positive, and by looking at these trig ratios, that confirms that. Cast is just a means to check our work, but at the same time, we can recognize that because we've assigned this value as being -3 into our x, that's why the cosine and the tangent already come out as negative. One last thing to consider would be to rationalize the denominator, because we don't want a radical in the denominator, so we can then multiply numerator and denominator by root 13, and we'll do the same over here. That then simplifies to 2 root 13 over 13 as my sine ratio. My cosine ratio is then -3 root 13 over 13, and the tangent is fine. We might consider moving the negative into the numerator or out front. So hit pause and try to complete class example number 2 on your own, and I'll work on that example and come back with an explanation in a moment. So taking a look, I've drawn that in, and we can see that the point -4, -2 lying on the terminal arm, that's going to be in third quadrant, and so we need to figure out what the value of r is, or our hypotenuse, since we're looking for the sine ratio, and the sine ratio is y over r, or opposite over hypotenuse. So using Pythagorean theorem again, we end up with r is equal to root 20, but of course 20 has a perfect square factor, which is 4, so we know that root 20 is the same as root 4 times root 5, which is the same as 2 root 5. So we can then substitute that in, so sine of theta is equal to y over r, or -2 for our y value, over 2 root 5. 2 over 2 is the same as 1, so that's why we can say sine of theta is -1 over root 5. And again, rationalizing the denominator means that I multiply numerator and denominator by root 5 over root 5, which is why we have -5 over 5. So I'm going to pause that there, or stop that there, and please go on to the second recording.